Okay, we have a problem. We got a problem. Do we have a problem? We have a problem. This problem states in a study for the NASDAQ stock market, it was determined that 20% of all stockholders, why'd I say stockholders, investors are retired people. Suppose a random sample of 25 stock investors is taken. So I know that a probability that they are a stock investor, retired person, is 0.20. I know the probability that they're not, which is our Q, which is 1 minus P, would be 0.8. And then I also know my number of stock investors is 25. Because they're either retired or they're not, this is a binomial. I have a probability of success, I have an N, and all that good stuff. So it says, what is the probability that exactly 7 is the probability X equals 7. Do you remember the formula? Oh, no, I don't remember the formula. So the binomial formula is, remember the first piece is the combination piece, so n factorial over x factorial n minus x factorial. So in other words, the number of ways you can get exactly 7 out of 25, and then times the probability of success raised to the number of successes, and then times the probability of failure raised to the number of failures, which would be your sample size minus the number of successes. So with that being said, then we write this out. So my N is 25 factorial over my X is 7 factorial, and then 25 minus 7, factorial. That junk over there is going to be in my way. And then times 0.2 raised to the number of successes times 0, we'll put these in parentheses, times 0.8 raised to the number of failures. So in other words, the probability they're retired, and then versus the probability they're not retired. All right, so to be able to actually work this out, and you should be able to do this manually, is remember that 25 factorial means 25 times 24 times 23 times 22 times 21 times 20. You're going, really? Is she going to go all the way to, no, I'm not, times 20 times 19 times 18. Why'd I stop there? So 25, 24, 23, 22, 21, 20, 19, 18 factorial, which would be all the way back down to the bottom. And then 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in the parentheses, 25 minus 7, well, that's 18 factorial. Now you see what you see what I did there? That's what I did there. And then still times the 0.2 to the 7th, 0.8. Now we can actually write this to the 18th power. All right, so if you're having to do this in the classroom, and you could probably type these numbers in pretty quickly, but there are things, I could say 7 into 21 3 times, 5 into 24 times, 4 into 24. I'm just making this a little bit smaller. Ooh, look at 6 into 6. I'm just making these numbers smaller so they're a little bit easier to do the calculations. And 2 into 22 11 times. So I get 25 times, all that went away, 23 times 11 times 3 times 4 times 19. And then I'm dividing by 3? So this number is 480,700. And if you remember, there's actually a way, because I'm gonna check myself, because I get writing and I don't know sometimes what I'm writing. But there's a way in the calculator that you can type 25, and then you can go to math, and then you can go to probability, and then you could go to combinations. And then you can put 7, and hey, I got that. I know you probably can't see, but can you see that? I got that number. So I done good. And so now I'm going to take that and multiply it by 0.2 to the 7th power and 0.8 to the 18th power. So I take that number, 0.2 raised to the 7th power times point. Are you doing this with me? You ain't making me do this all by myself, are you? You're doing it with me, right? And I multiply all that out and I get 0.1108. Good job. As I mentioned before, if you're able, and meaning like you're not taking a test and you don't have to do this by hand, you really should do it here in Excel, right? Because it's certainly faster. So we know this is a binomial.dist. It says right here the number of successes. Well, I wanted what, 7? Probability of success, 0.2. Oh, I'm not reading. The next is the number of trials, which is the sample size, 25. Probability of success, 0.2. And then I don't want it to add anything up. I want exactly this value. I hit enter and hey, there it is. There, you see it? It's right there. So that's good. All right, so we know we're going to use this formula. All right, so I'm not going to redo the formula for all these. You could practice and do the next one. But basically what I'm doing is, I'm getting a different color so you can see it, is I'm looking at how to read these, and it says, what is the probability that 10 or more are retired? So the probability 10 or more would be the same as 1 minus the probability less than 10. And so that's still kind of a big deal, right? Because you're having to do, either way, the more than 10, you would go all the way 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So you go to 25, right? And the other way, you'd go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, so whichever way you decide to do it. I actually did it this way because I started getting zeros very quickly. So I did the probability x equals 10 plus the probability x equals 11. And this would just give you something to check it because you're doing this, right? You're practicing. And plus the probability x equals 12. And then plus the probability x equals 13. All right, and when you do that, you should get something like 0.017, something like that. All right, so go do it. Pause me and go do it right now. All right, how many retired people would you expect? Expected value, the expected value in a binomial. What happened? The expected value in a binomial, what's formula? While I'm sitting here trying to get my ink pen back, what's formula? Do you know it? Do you know it? Do you know it? Sure you do. Would you stop doing that? So you're already telling me the formula, or you're looking for it because you can't find it, right? So the formula is just n times p. And n is our... It's killing me, man. It's killing me. So n is our sample size. I must be hitting something with my hand here. So 25, my sample size, and then times my 0.2, right? So my sample size times my probability. And if you multiply that, you should get 5, which says how much you should expect to get. And that's all, folks.